Welcome friends to the new session. Uh, Not new session. This is the fourth class on our classical mechanics. Today we are going to talk about the Hamiltonian. Today we are going to talk about the Hamiltonian. We will thoroughly study this. Okay, don't worry. Keep watching this lecture. It will be helpful. Okay. So let me define Hamiltonian. Hamiltonian is nothing but the energy integral, we can say. This is Pi Qi dot, the definition. You must know this is the definition of Hamiltonian. So basically, what does it mean? We generally Hamiltonian to Lagrangian conversion and the vice versa. We do the question comes on the topic like to convert. You have to convert the Lagrangian into Hamiltonian. If Hamiltonian is given, you have to find out the Lagrangian of the system. So this is the way they are asking you the question. If some system has Lagrangian is given, you have to find out the Hamiltonian. So we'll read those problems and we'll solve those problems. Okay. So be with me. Del S by del T is equal to minus dou L by del T. You have to remember this formula. Okay. So let me write the Hamiltonian equation in Poisson bracket. Hamiltonian equation in Poisson bracket. How do we write this? So we write this like in this way. Function of P and Q, summation over I, dou X, dou Pi, dou Y, this is dou Qi, and this is Qp. We generally write in this format, dou Pi minus dou X upon dou Pi, dou Y upon dou Qi. Okay. Suppose you have a question in this way. Write Hamiltonian equation in Poisson bracket. Equation in Poisson bracket. So how do we write this? We write this in this form, in this way, Q and H. This will be Q dot dq by dt. Similarly, PH, Poisson bracket, this will be P dot dp upon dt. Clear? Yes, it must be clear to you. Then we have if some question. Okay, I have one question for you guys. The question is like this: if the Lagrangian of a particle is given as L is equal to 1 by 2x x dot square minus v of x. Okay. So you have to find out the Hamiltonian. What will be the Hamiltonian? Let me solve this for you. So Hamiltonian is, what is the formula of Hamiltonian? This is nothing but Pi Qi dot minus Lagrangian. So here the Qi, the generalized coordinate is only one, that is x. So I can write this x dot p minus l, isn't it? So I have to find out the Lagrangian. What will be the Lagrangian? I know Lagrangian is given. So I can write 1 by 2x x dot square minus vx. And x dot. In order to find out x dot, what I will do, I will just differentiate with respect to x dot. So differentiate. If you differentiate it, you will get 1 by 2. X will be like this, and this will be 2x dot minus 0. So it will be nothing but x dot upon x, isn't it? And we can write x dot as x into p. Clear? Okay. This is I got x dot, so I can now easily write the Hamiltonian. Hamiltonian is x dot p. So in place of x dot I can write xp and p minus the Lagrangian 1 by 2x in place of x dot, again you write xp square plus b of x, and it will become xp square minus half xp square plus b of x, and if you subtract this you will get half xp square plus b of x. So this will be your final answer. See how simple it is. You have to just find out the x dot, the velocity coordinate in terms of your x and p, and you got your answer. Let me do another question for you. In this question, you have to find out the Lagrangian. Okay. In order to find out the Lagrangian, it is given the Hamiltonian is like this: p theta square minus 2ml square plus mgl 1 minus cos theta. Okay. You have to find out L first, and then you have to evaluate dl upon dt. Let me do this for you. Okay, in order to find out my Lagrangian, I know my Hamiltonian is, if I will write the Hamiltonian in this case, this is the function of theta and p theta, isn't it? So I will write how? Theta dot p theta minus Lagrangian. If I have to find out Lagrangian, so I can write theta dot p theta minus h, isn't it? So I have to, in order to find my Lagrangian, I have to calculate theta dot first. So how can I calculate theta dot? Let me do this for you. So theta dot is nothing but dou h upon dou p theta, and you have your Hamiltonian. The Hamiltonian is how much? P theta square divided by 2ml square plus mgl 1 minus cos theta, and you are differentiating with respect to p theta. So the second term is 0. If you differentiate the second term in respect to your p theta, that will give you 0, and you will only get p theta upon 2ml square, isn't it? Isn't this you will get? Okay, so 2ml square, I guess you will get if you differentiate. Let me differentiate for you. Okay, we are doing dou h upon dou p theta. If you differentiate, you will get how much? 2 p theta upon 2ml square, and this term will be 0. So 2 getting p theta upon ml square. So I will get here only ml square. Okay. And next just put it in place of Lagrangian. P theta square upon, we have theta dot square now, theta dot p theta. Okay, theta dot I got p theta square upon ml square minus the Hamiltonian. Hamiltonian is given to you. Hamiltonian is how? What is the Hamiltonian? P theta square 2ml square plus mgl 1 minus cos theta. We are subtracting, so this will become your minus. This will become minus. Okay, I hope you are getting it. If you subtract this, you will get half p theta square ml square minus mgl 1 minus cos theta. Okay, so this is the Lagrangian of the system.